Okay, welcome back to Algebra Intensive 1A. This video is going to go over LEP 5, Day 1. So if you haven't done so already, go ahead and do this self-assessment, going over the 3 learning goals in this packet. Pause this video and do that now. Once you're done with that, let's go ahead and move on to the LEP opener. A homeowner is looking into installing solar panels for his home. He is having a hard time deciding between 2 companies. Below are 2 pricing options for the installation. So here we have Sunshine Solar Panels with $9,600 installation, paid off at a rate of $600 per year. And then we have Ray's Solar Panels with a $7,000 installation, paid off at a rate of $1,000 per year. So they start off with owing, for Sunshine's pricing, owing $9,600, and we're paying it off $600 per year, so that's a negative $600. So let's go ahead and fill in this table where we're paying off $600 per year. So $7,800 minus $600 is $7,200. And then minus $6,000 again is $6,600. And then minus 600, I'm sorry, not minus 6,000, minus 600 is 6,000 here. And then minus 600 again, 5,400. So here, after 7 years, they still owe $5,400. Or he would still owe, the homeowner would still owe that much. Let's check out Ray's pricing here. We have $7,000 installation fee paid off at $1,000 per year. So filling in this table, subtracting 1,000, and so on, right? So 4,000 minus 1,000 is 3,000. Then we have 2,000, then 1,000, and then 0. So here, after 7 years, it's totally paid off. So we don't owe any more money. So go ahead and answer these 2 questions. If you had to choose one company over another, which would you choose and why? And then if you had to put $3,000 down for the installation, would you still choose the same company? So go ahead and pause this video, complete those 2 questions. Okay, so now we're going to go over day 1. It says topic 1, but it should say day 1. Ratio concepts. So the do now, complete the ratios. At a school recycling day, there are 16 volunteers for every 2 classrooms. So I'm going to set up, so the number of volunteers to the number of classrooms. I'm going to go ahead and draw what this means. So here we have 16 volunteers. So we have 1, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then we have 2 classrooms. So 2. So here this is 16 to 2. Now if we have 4 classrooms, here we would have, if we had 4, each one would be 2, right? So if each box was 2 here, this would be 2 times 16. So this would be 32. So that's one way to do it. Another way to do it is to set up this ratio. So I'm going to set up this ratio up here. So this ratio of 16 volunteers to classrooms. I'm just going to put class. So there's 16 to 2. So here for our next one, how many volunteers for 6 classrooms? Well, if there's 6 classrooms here, how many volunteers would we need? Well, 2 times 3 is 6. So 16 times 3 is 48. So this would be 48. And then one last thing I want to show you. So you have the model, you have the equivalent ratios we can make, and we can also make equivalent fractions. So if we put volunteers over classrooms, we can make equivalent fractions. This is kind of like making equivalent ratios as well. So 8 volunteers to how many classrooms? So we have 8 on top, volunteers on top, over classroom. So 16 to 8, how do I get from 16 to 8? Well, I just divide by 2. So if I divide by 2 here, I'm going to get 1. So that's 1 classroom. Okay, so I can make a table, I can make equivalent fractions, and I can make equivalent ratios. So I'm going to explain that here. So making a model, equivalent ratios, and equivalent fractions. So find a way that works for you and do it that way. Okay. So let's go ahead and go over some vocabulary terms. The number of times a number, the base, is used as a factor in the same term. So here, when we're talking about exponents, like 4 squared, this is saying 4 is being multiplied by itself twice. So that means 4 times 4. This is the number of times a number is used as a factor. So here, this is the exponent. The exponent tells us how many times we have to multiply the base. So 4 raised to the power of 2 is 4 times 4. We're multiplying 4 twice. So really that would be 16, but we don't need to do that. That's just an illustration of what an exponent is. Okay, and then the next one, a value that does not change, that does not vary, a fixed quantity. So here this is a constant. It doesn't change. That would be constant. And then last but not least, a number or expression that is used as a factor more than once. So here when we had 4 squared, if we had 4 times 4, this factor is being used more than once. So this, we would call this a base. The base is 4. And then obviously the 2 is the exponent. Okay, so we have base raised to the exponent there. Okay, moving on to day 1, lesson 1, model unit ratios. So going over the worked example, at a research site, the ratio of botanists to geologists is 2 to 1. What is the multiplicative relationship between botanists and geologists? Okay, so here we have, for every 2 botanists, we have 1 geologist. And that's what step 1 tells us. There are 2 botanists for every 1 geologist. So here, if we model another situation, there are how many botanists for every 4 geologists? Well, if this was 4, how many botanists would there be? Well, there would be, each of these boxes are the same, so there would be 8 here. And so that's how they got that 8. And again, that was step 3. You can also set up a ratio from, so botanist to geologist. So there's 2 botanists per geologist. And if we want to find out, we know that there's 4 that we want to find out, or that it's given to us, but we want to find out how many botanists there are. Well, let's just complete this equivalent ratio. 1 times 4, 2 times 4, 2 times 4 is 8. So that would be 8. So if you want to use the model, go ahead and do that. If you want to use equivalent ratios or fractions, go ahead and do that. And then, last but not least, finding the multiplicative relationship. So how do we get from geologist to botanist? So the number of botanists is just twice as many the number of geologists. All right, so we get, this is 4 times 2 here. This is 1 times 2 here. So we multiply by 2 to find the multiplicative relationship. Or we can think about, let me illustrate it here. Botanist is equal to geologist times how much? So if we just plug in a ratio, like 8 to 4, 8 is equal to 4 times how much? Well, that's just 2. So our multiplicative relationship is just 2. Okay, so let's go ahead and try it. Each kilowatt hour of electricity costs 7 cents. For every 1 kilowatt hour, we have 1, 2, 3, 4, 5, 6, 7 cents up here. What is the multiplicative relationship between the number of kilowatt hours used and the cost? So let's go ahead and do the same thing where we model another situation. So what about instead of 1, let's have 2 hours here. So we know that our first is, so there are, or the cost, we'll say the cost is 7 cents for 1 hour. What about for 2 hours? So let's see, if this was 2, each of these would be 2. So how many do we have here? 2 times 7, or 7 times 2 is 14. So that's another ratio. We have, we'll do the ratio of cost to hours is, the cost is 14 here to 2. And then let's find the multiplicative relationship. So here the cost of electricity, so we want cost of electricity is equal to the number of hours times what? This is our multiplicative relationship. So if we go ahead and plug in our first ratio, or even our second, we can use our second as well, but I'm going to do the first. So our first was 7 to 1. So for 7 cents, we have 1 hour of electricity. 1 times what number is 7? Well, it's just 7. Okay, let's check the next one. 14 to 2. So 14 cents is equal to 2 times what? Well, that's 7. So our multiplicative relationship must be 7. So the cost of electricity is 7 times the number of kilowatt hours. Cool. So that's how you do those ones. Go ahead and complete this practice section based on what we just went over, and I will see you back here for the next lesson. Okay, so this next lesson is a bingo game, and if you do have another person with you, you can try it together. You can also do some on your own. It's kind of hard doing this remote, but we will go ahead and do a couple together. So here we have all these shaded and unshaded figures. So in this number line right here. So I'm going to, I'll circle and I'll put shaded and then I'll put unshaded. So just choose 2 random numbers. And go ahead and log those in. So I have 2 for shaded. My comparison will be shaded to unshaded. So 2 to shaded and then 4 for unshaded. And Okay, yeah, we're doing it right. So here, I'll be X's or I can be O's or whatever. I like X's, so I'm going to do X's. I'm going to find 2 shaded figures to 4 unshaded. So I see right here there's 2 shaded, 1, 2, 3, 4 unshaded. So that's my X. And then it's the next person's turn. So you can either go back and forth between X's and O's. You can play with a partner. You can just see how many you can get in a row. So the next one would be, let's see, let's do 3 shaded, 6 unshaded. Is there 3 shaded and 6 unshaded? Maybe I did too much. I do not see it. So maybe I'll do something like, I'll do 3 shaded and 1 unshaded here. And I see that right here. So I can be X's or I could be O's. So at least do 5 or so on this page. So if I wanted to do unshaded to shaded, if I wanted to write it like that, my unshaded was 1 and my shaded was 3. So 1 to 3, that was this guy right here. Okay, so go ahead and just do a handful of those and we can move on to the next lesson. Okay, pause this video and do that now. Okay, so this is an algebra lesson because of this learning goal. Let's go over it. I can recognize that a linear equation has a set rate of change between the 2 values listed. So here we're understanding linear functions. Let's go over the worked example. There are 2 proposals for a recycling plan listed below. Fill the tables and decide which plan has a constant rate of change. Constant rate of change. So that means it's linear, right? So this would be linear. It doesn't change, right? So plan 1, increase the processing of recyclables by 2 tons per month. So here, they're just adding 2 each time here. Filling out this table, and then doing the same thing for the next one. So double the processing of recyclables per month. So now we're doubling it. So we had 2, double it, we get 4. Double that, we get 8. Double 8, we get 16, and so on. Double 16, we get 32. So choose a plan that has a constant rate of change and explain your reasoning. So I choose plan 1 because here, if we look, this is like the rate of change. This is constant versus this, which is not constant. And you can see here, this is an exponent, a base raised to the exponent. So this is an exponential model. And this is a linear. We're just multiplying by 2 each time. And so plan 1, because the increase in recycling happened at a constant rate. So looking at the change of rate, the rate of change, this one's constant. And we can just say this one's not constant. Okay, so let's go ahead and try it. So again, which one of these water taps regulates water flow at a constant rate? We want linear, constant. Fill in the tables and choose the tap that has a constant rate of flow. So here, water flow increases 3 times the amount of the previous minute. So here, it's 3 to the x. So 3 raised to the 3rd power is filling out this guy. 3 raised to the 3rd. Is 3 times 3 is 9, times 3 is 27. So this is 27. And then if we multiply it by, we go 3 to the 4, 3 to the x when x is 4. Well, that's just 3 times 3 times 3 times 3. We know 3 to the third, that was 27, times 1 more 3 is 81. And then 3 raised to the 5th power. Well, we know 3 raised to the 4th. So 1, 2, 3, 4. We know that. And we're multiplying by 1 more 3. So that was 81 times 3. So that's 243. So here, as you can see, the rate of change let's see, 81. Finding the rate of change here, we have 6, 18. 81 minus 27 is 54. And then how do we get from 81 to 243? How much do we have to add? Well, let's find 243 minus 81, that difference there. That's plus 162. Okay, so here we want to be looking for the rate of change. So this is not constant, right? So let's go ahead and take a look at the next one. Water flows at 4 gallons per minute. So here each minute we're just adding 4. So 4 plus 8, or 4 plus 4 is 8, 8 plus 4, 12, 12 plus 4, 16, 16 plus 4, 20. So each time we're adding 4. 4 times 3 is 12. So here they give us this model. Y is equal to 4x. But here I just added 4 each time. You can go ahead and plug in each one. So the next one would be 4 times 4. That's 16, and that's how we got that number. And then when x is 5, y is equal to 4 times 5. That's 20, and that's how we got that last number. Okay, so you can use the model or the table, whichever one you would like. So which one's the constant rate? Well, that's plan 2. Would that be tap 2? Okay, tap 2. Because, so each minute water flows at a constant rate. So from minute to minute, we're just adding 4 each time. Okay. So let's go ahead and pause this video, go ahead and give this a shot, and then I will go over it in a bit. Okay. Hopefully you attempted this. So 2 60-gallon rainwater tanks are drained so that the water can be used for watering crops. Fill the tables to see which tank is draining at a constant rate. Which of the 2 tanks will be emptied first? Use the formulas to fill in the tables and check your answers by graphing. Okay. So tank 1, this model is 2 to the x plus 2. So 2, let's do 3 and 4. So they already did 2 for you. They did 1 and 2. So 2 to the x plus 2. When x is 3, let's go ahead and replace that x with 3. So here this means we're multiplying 2 3 times. So 2 times 2 times 2. And then we're adding to that 2. So 2 times 2 is 4, times 2 is 8. So this is 8 plus 2, that's 10. And when x is 4, 2 to the 4th power plus 2. Well, 2 to the 4th power is 2 times 2 times 2 times 2. It's multiplying 2 4 times plus 2. So 2 times 2 is 4, times 2 is 8, times 2 is 16, plus 2 is 18. Okay, and so now let's find the rate of change between values. So they did 4 plus 2 is 6, 6 plus 4 is 10, 10 plus how many is 18? Well, that's just 8. So you can see here this is not changing at a constant rate, right? Because we have that exponent, so it's not constant. Let's try this one. Again, let's do 3 and 4 because they haven't done it with this model. So y is equal to 2 times x plus 4. So instead of x, we have 3. 2 times 3 plus 4. 2 times 3 is 6 plus 4. That's 10. And then we'll plug it in for 4 when x is equal to 4. 2 times 4 plus 4. So 2 times 4 is 8. Plus 4 is 12. Finding the rate of change, 6 plus 2 is 8. 8 plus 2 is 10. And lastly, 10 plus 2 is 12. So that one does change at a constant rate. Tank 2 does change at a constant rate. So let's go ahead and plot them. So x and y values for each. So again, they did 1 and 2. 3, we got 10. So I go to the x-axis, 3, and I go up 10 is right here. So where they meet, I plot that point right there. And then 4, 18. So 4, 18 is going to be like way up here. We'll say 18's there. And then 4 is right there. And so it's not linear, it's like increasing. Oop. Super quick, right? So it's not quite linear. Let's try tank 2. So 3, 10. There's 3, 10. And then 4, 12 is just above that. And so that looks more like a line. So tank 1 or 2 will be emptied first. So which one's beating the other? So here at minute 4, over here, oop, let me get a thicker one. At 4 minutes, we have 18 gallons. And then at 4 minutes, we have only 12 here. And remember that this rate of change in tank 1 is increasing. So we're going to be getting higher numbers on tank 1, or the water's going to be draining quicker at a quicker rate each time. So here, tank 1 will be emptied first. Let me just circle that. And then which one drains at a constant rate? We already said tank 2 drains at a constant rate because that's linear. Okay. Cool. So go ahead and pause this video and do this practice section on understanding linear functions. Again, we're looking at the rate. So what numbers you get here, that's our rate of change. And if it's constant, that's what we want. If it's not constant, then that's not the plan that we're interested in, right? Go ahead and do that. And then you have this other page as well. Same thing though. And then the exit ticket. And that's about ratios, what we did on the first lesson. So checking, once you're all done with that, oh, I thought I had the software here. Make sure you do the software for LEP 5. That's attached to the, let's go to classroom actually. Let's see. So you can either do software, it's available on the feed right here. So software, we are on LEP 5, so click on that tab. So for day 1, you're doing block 2, topic 2, lesson 2, and then you're going to do block 2, topic 2, success zone. So it's lesson 2, and then the success zone, and then you're done.